So this is what the phasor diagram looks like. Now, normally we cannot start because delta is unknown. Hey man, what's wrong with me tonight? Right, so first thing is we have to determine delta, and we use it by saying E angle delta is V angle 0 plus IA angle plus or minus phi times XQ at an angle of 90 plus IA RA. Then we will get a value at an angle. That is the delta that we are going to use. And then once we've got that, we have to split up the current IA into two components, i.e. the quadrature current and the direct current. Now we do it according to this. So ID will be IA sine. Now look, that is the angle that we are going to use. And that will be phi plus delta. And IQ is equal to IA cos phi plus delta. Now once we've got that, we can start write down the equation for E. So E angle delta is V angle 0 plus IA RA at an angle plus or minus phi plus ID XD, and the angle is the same as delta, plus, now that is ID XD, and that is IQ XQ.
So we can't see the rest of the paper. Thank you.
So therefore, plus, so that'll be IQ XQ angle 90 plus delta. Now with that, we can determine the induced EMF. Okay, sorry. And plus IA. Oh, I've already added it. Bloody mampara. Okay. So therefore, now we can determine E. And then once we've got E, we can now start doing something. First of all, we can calculate the developed power. That will be EV over XD sine delta plus V squared over 2 XD minus XQ over XD XQ sine 2 delta plus IA squared RA. Now normally, if RA is not given, you can ignore the last term. And there as well. So you just leave it out. Then we can determine the maximum value. What is that going to be? You must study the chapter. What is it going to be?
The maximum power is the same formula, but your load angle is going to be maximum.
Huh. So how do we determine that?
You must get load maximum load angle, which
Yeah.
is cos
So first of all,
load angle maximum.
cos of delta.
Maximum.
Cos.
Okay, minus E.
Cos delta is equal to
Minus E
okay.
XQ over 4.
Okay, now you've got the difficult one. I like this one. Minus K1 over 8K2 plus or minus or just plus, no? Okay.
Oh, you want that one?
And the square root of
Plus or minus
K1 over 8K2
squared
plus 0.5,
half.
where K1 is equal to EV over AV and K2 is V squared
V squared into XD minus SQ over 2XD XQ.
That's it. Right, and then we can determine.
Sir,
Yes.
it cos, not a cos.
What?
It cos, not a cos. For
Oh,
the load angle.
so now can't you see that one again? Thank you. All right.
I saw it.
Huh? You saw it, but you remained silent.
Yes. So I didn't want to strike with you. I don't want to strike with you.
Oh, sure. Now only. Okay, so now we can determine the maximum value. So P developed max will be EV over XD sine delta max plus V squared over 2 XD minus XQ XD XQ sine 2 delta max. Okay. And basically, if you understand this, and you've got this question, then you can get it, all of them correct. Because they all, this is the formula, this is the recipe for determining everything. All right, so let's do example in the exercise. One that's Ona been plaguing me with since last week. Hey, Ona?
Sir, let's do number 2. Number 2.
Yes, yes. So we've got a 11 kV. 11 kV, 20 pole, star connected salient pole with the load current 1000 amp. Power factor is 0.8 lagging. RA is 1.2 ohms per phase. XD is 4.8. And XQ is 3.6 ohms per phase. So always remember, you start off by drawing your phasor diagram, because I'll tell you just now why it's important. Let's say that's IA. And I'm going to make it too small. What have I done to my little cap? All right, let's say it is there. And so that we can see that is IQ and ID. IARA. IDXD, IQ, XQ. Okay, and this is phi. Now, first of all, we have to calculate delta. So E angle delta is V angle 0 plus IA XQ 90 plus or minus phi plus IA RA at an angle plus or minus phi. All right, in this case, it's then 6350,85 angle 0 plus 1,000 times 3.6 angle 90 minus 36,87, plus
Yes, sir.
IARA, it's 1,000 times 1,2 at an angle of minus 36,87. And that boils down to 9714 at an angle of 12.85. Okay, now can you see this is a right angle triangle? Let's do it that way. There's our 90 degrees, there's IA, and that is our angle. So IA cos. So therefore, IQ is equal to IA cos of phi plus delta. Can you see that's why that angle there is phi plus delta? Okay. So therefore, that will be 1,000 cos of 36,87 plus 12,85. How much is that? And then ID is equal to IA sine phi plus delta. All right. So that's 1,000.
IQ 646
646.
46,524. 524.
Okay. Thank you. And then this one is 1,000. 36,87 plus 12. All right, the sine of that. Come on.
762,894.
762,894.
94.
Okay, now we're ready. So E angle delta is 6350,85 angle 0 plus 1,000 times 1,2 at an angle of minus 36,87 plus ID is 762,894. ID, what is the angle of ID?
It's 12.85. The load angle.
ID is there.
Yes, sir. Your ID what? XD.
Yeah. So that angle there is the same as delta.
There is delta.
12,84.
12.885.
Okay, times 4.8. 4.8 angle 90 plus
646.
646, 524 at an angle 90. What's that? Plus delta plus 12,8485 times 3.6
Yes, 3.6.
angle 90. And then if you don't get 12,85, you made a mistake somewhere. Now, normally, a problem like this almost counts 20% in the exam. So yeah, you can see, if you use this recipe, you can't go wrong. Except if you are exceptionally stupid. Right, in the meantime, we developed,
So the answer is
yeah,
10,629, 519.
5, far enough. Angle 12.8,
Yes.
great stuff. So EV over XD sine delta plus V squared over 2 XD minus XQ divided by XD XQ sine 2 delta. So that will be 10,629,5 times 6350,85.
Sir,
Oh,
don't forget to add your I squared R because we are given R.
can you see it now?
Yeah, bo.
Okay. Right. XD 4.8, no?
Yes.
Sine 12,85 plus 6350,85 squared over 2. And then 4.8 minus 3.6, 1.2 divided by 4.8 times 3.6. Sine 2 times 12,85 plus 1000 squared times 1,2. And remember that is per phase.
Okay, the one that I got, it was 4.935 megawatt per phase.
Anyone agree? 4.35.
935 megawatt per phase.
Shit.
After multiplying it by 3, it's 14.805 megawatt.
So why is my answer 20?
I don't know. Check, calculate your E. Use your calculator. Maybe the problem is that E.
Damn, is time already running out? And then 6.4, 6.52 to the angle of 102.85. I made a mistake somewhere. Okay, doesn't matter.
Sir, it does.
Huh?
Why did you put there for IAX XQ?
No. Yeah, in the beginning, that is to calculate.
I mean ID, no, IDXD. You
Yeah.
put two angles. Why? Because now you must use another side of the Phasor diagram. What is the angle of IQXQ?
IQXQ. 102.
Yeah, from your diagram.
102.85. Is that one? 90 plus.
We don't see. We don't see. Can you take your page down?
90 plus
Yeah,
12.
it's 90 plus 5, ne?
Yeah,
Yes.
no, plus delta.
Yeah, plus a delta.
Yeah,
So I see there, you check there in your equation.
it's
What did you say?
102. It's 102.85.
And then your IDXD.
Is 76 IDXD.
It's not
Well,
only
yeah, well, that's the makeup. Bugger up. That's just
Oh.
4.8.
Yes, and that go on that other side. You have 90 plus load angle and another angle here by 3.6. Can you remove 190 there? You have a lot of 90s there.
It seems like it, no?
I'll say, yo, yeah, that answer is correct if you did that.
Then the answer is correct. Okay. All right, doesn't matter. Okay, now we can determine the maximum delta, no? It's R cos of minus K1 over 8K2 plus or minus the square root of K1 over 8K2 squared plus 0.5. So K1 is then 10629.5 times 6350.85 divided by 4.8. And then in K2 is 6350.85 squared over 2 times 1.2 divided by 4.8 times 3.6. Now normally that shouldn't be a very large angle if we get the answer there. Around about 60.
Your K1 it's 14,057.87, 1,109.
Oh, come on, like it like that. Are you sure?
Yes, do it in the calculator. Multiply by.
D. This I get 14,00461.66.
Yeah, it's fine.
Well, that's
Are we using plus or minus?
plus.
So when are we supposed to use minus?
I don't know. If you use a minus, you can check what is the answer.
Okay.
Oh shit, this is 32. I don't know, that's right.
I got 69.81. Check yours.
69.81. Did you subtract?
Yes.
4, 6. Oh, shit. Six.
$90. Is it 90? Yeah.
Change sign? Huh?
90 or what?
G squared 0.5 plus minus. No. It must be the plus. 140. I got 53. All right, doesn't matter really.
I'm still confirming.
You what?
I'm checking if I punch very correct.
Yeah, that's the question. Anybody else got another answer?
Yo, it give me 97.
No. Then you've used the minus.
When I use my minus in 96.
No. Let me try again.